Okay, so now what we're going to do is we're going to go ahead and download. So we'll click this and say download. Download now. It should take fairly quick. Depending on the size of your program, this might take some time. So we're going to put it back in run mode, and then let's look at this. Now you can see a few things about this, and I know I covered a lot of these topics in earlier courses, but you can see I am in remote run mode, and it's green. It tells me the position of the lights on the CPU itself. It says I'm in run mode, the controller is okay, and if I had I/O troubles, this light would flash. I have no edits and I have no forces on. Okay, so let's slide over to here. Now we can just go ahead and add a number in here. We'll say that's 100, and 100 plus 0 in this case is 100, right? So we'll add 5 here, and this is 105. So we could have tank, the first tank, if you will, or the primary tank had 100 millimeters of water in it or whatever, and tank 1 had 5 millimeters of water, and then tank plus tank 1, which is just a unique tag number that I created, would be 105. So that's how that works. Now the next thing I'm going to show you is how to do online edits. So you slide up here, and you can actually do this online and add an input. Now you can't do this to all processors, but this emulator you can do this to. So we're going to subtract. So we'll subtract tank, and then let's go ahead and hit this arrow because we're lazy, and it gives us the tags that we've created. Tank 1, tank plus tank 1, and we'll subtract tank from it. Let's subtract tank 1 from it, and let's put that in a new tag, and I don't know if it lets you do this online or not, but let's do it. Let's see, this is tank plus 1. Here, we'll just do this. Sub, tank sub. And then let's right mouse click on that and say new tank sub. Now not all processors will allow you to do new tags online like this, and you can see this is in the main program. It's a decimal and it's a double integer, and we can say OK to that. Now we've got these eyes. You see the eyes right here? So now what we need to do is we need to activate that, accept the pending edits, and then let's hit this little test accepted program edits and say OK. So here it gives you some warnings and tells you different things, and say yes, and then we should accept that. So basically when you do an online edit like that, before you actually accept it, it's sitting there saying, okay, you sure you want to do this? And you can go in to test it. You can actually look at your Logix and see if it actually operates the way you want it to before you download it. And what you would do this for is if you actually have an active plant, you don't want to shut it down, and you just want to make some minor changes or adjustments, you can do it without shutting the plant down. So again, the sub instruction is tank plus tank 1. It's 105. Tank 1 is 5. And then if we subtract that, we're back to a 100. And that's how the sub instruction works. Now, if you click on sub right here and you hit F1, it will pull up the help screen, the help menu. And usually it jumps right to the sub, but we can actually hit help topics. And it'll say minimize the database and say next, and then finish. And what it does is it creates the database for you. And then you can type in sub. And then it'll give you, here, this is an add instruction. I don't know why it jumped to an add instruction. That's kind of odd. Oh, I didn't hit it. I hit the opposite because I went here. I clicked there. So let's go to sub. And there it is right there, sub instruction. And so it tells you about the sub instruction. So when you download this, you can see this is in Relay Logic right here. This one is in function block. We haven't covered function block yet. We probably will do that in a later, more advanced course. Some people prefer the function blocks as opposed to the ladder logic. And then it tells you the different types of data you can put in there. You can do the S integer, integer, D integer, real, and source B obviously has to be the same. So if you have a D integer here and a real here, you're going to get a real. that. And then it gives you some different information about this. So that's how you get the help screen, and you can actually study some of these different routines. And then obviously the description's fairly straightforward. The sub instruction subtracts source B from source A and places the results in the destination, which we've just seen. Okay, so let's see which one is the next one. We want to do a multiply now. Let's again do an online edit. So we're going to add a rung, and then we're going to do a multiply. So this time we're going to multiply tank by tank 1 and store that in tank multiply. Now again we have to create that tag, new tank multiply, and say OK. And then let's accept those pending edits. There's quite a few extra steps you have to do when you're online. So when you're online, it doesn't really make sense to program a big PLC program, because it takes time, and you have to do so many different steps. So what you want to do is you want to go offline if you have to make a lot of changes, or start the code from, you're just starting out and you're going through all your alarms and controls and etc. Then you want to go offline, make all your changes, and then go online. So here we have tank, which is 100, multiplied by tank 1, which is 5, and the destination is tank multiply. So these are very straightforward instructions you can use. Okay, let's do another one. The divide. And so let's take tank multiply and divide that by tank 1, and then we'll call that tank multiply or divide. Now if you divide by 0, you can fault the PLC. So you want to make sure you don't do that. Oh, and what is it telling me? I'm trying to download it, and it's saying it can't accept this. So you've got issues here, right? So if we were to slide up, it should tell me error. It didn't tell me the errors, but we'll go ahead and slide that down. And we know what the error is. I haven't created that tag, and I haven't gotten rid of the E's. Remember, if these are E's in RSLogix 500, you were just able to right mouse click, say verify logic, right? But in ControlLogix, you can't do the right mouse click or the verify logic. So you have to actually get rid of the E's. And the way you get rid of the E's is to actually go through this. Hold on. Okay, there. Accept this. The nice thing about the emulator program is it does allow you to, offline, not in front of everybody on the test floor, you can actually play with these different pieces of code. And once you understand them, you can actually go out there and download with some confidence. And you need to play with these programs and feel confident about this. So when you do have your company that you work for, invest in RSLogix 5000, because that's what I recommend. Is you actually go out there and get off the 90-day version, get off the free 15-day simulators, and invest in these Allen Bradley products, because they are excellent products. And once you learn this skill, there's no going back. You will definitely make a lot more money, and especially if you get good at it and you take your time and you use sound ideas and don't get too fancy with your MC, your jumps and all this different stuff. Keep it straightforward. Keep it to 5, 6 instruction types, and try and stay within those. And you'll be much better off. You'll have better programs, and you won't have any problems there. Let's go ahead and try and fault this. Let's divide by 0. See what happens. And this old emulator, it didn't fault. What a champ. So I think we saw that in a previous one. Okay, so let's add another one. Is the mod. Remember the modula instruction divides source A by source B and places the remainder in the destination. So type in MOD. That's another way you can do this. Remember, you can actually just type in the instruction and it drops it right in. So here we're going to take tank 1 and we're going to divide it by 5.5. And we're going to store that in tank 2. So we're going to go ahead and make this a real value. It didn't. We can probably leave it a D integer. Let's see what happens. So if you take 5 divided by 5.5, oh, we better change that. Hold on. Change it to real. It won't let me do that. Hold on. Let's go offline. Slide over here. So we've got 0. So let's put a 500 in here. Let's say that. 500 divided by 5.5 gives you the remainder of 5. We can put here 2. 2 divided by 5.5 gives you a remainder of 2. Let's do one other thing here. Let's just type in div divide. Let's take tank 1 divided by 5.5 and call this one tank 3. And we're going to make this a real. Oh, I misspelled tank, didn't I? Now we can download it. Okay, so if we take tank 1, let's say it's 100, divided by 5.5 is a is 18.181816. So the remainder here in the mod is just 1, remainder 1. The next instruction we were looking at is the negate instruction. So we'll type in neg, negate, and we'll take tank 1 and call that tank neg. And this just changes the sign, right? So let's go over here. So tank 1 was 100, so the result, the destination, is negative 100. If tank 1 is a negative 4, then the result of the negate is just 4. So that's how that works. Let's see, what else do we have? We have an absolute value. So let's take and add that. And again, we can either go up here and find the absolute, and you can see it stops at square root, so we have to hit the arrow key until we find absolute. And we'll take tank 1 and take the absolute value of that and put it in abs, tank abs, and we'll say that's new and say OK. Accept that, and let's go ahead and test and accept the edits. Now you see the instruction here is actually working. So we're actually in a test mode right now. You can see it's actually taken the absolute value of -4 is 4, right? So now if we click this again, we'll actually assemble the edits and it'll run. So if we were in a factory floor right here, we would have actually assembled the edits and started running. Okay? So here's your negate again and your absolute value. So if we take tank 1 and say it's 7, we negate it over here, and that's -7, and tank 1 is 7, so the absolute value of that is 7 as well. Okay, now let's add another instruction. And we have a square root instruction. We'll take the square root of tank 1 and see what happens. Tank 1, tank squared. Let's save that. And if we say this value is 25, the square root of 25 is 5. Or the square root of 100 is 10. 144 is 12. So you can see this computer, this PLC logic, it's very simple. You can clearly see what this instruction is and how it works, and you can actually implement it very easily. Sometimes when you get into C or C++ or Visual Basic even, you get into syntax errors, and it's real easy to get hung up on that. And this visual language like this, it's not hard, it's easy. You don't have any problems at all. You don't get hung up on it at all. So that's the beauty of this. Let's see, what else do we have? We have the compute instruction, which I kind of like this one because now you can actually take instructions, let's say results. And these results, we want to go ahead and say, we're going to go ahead and make that a real. Say OK. And let's give it an expression. And let's say 56.3 plus tank 1. So you can bring in different instructions and see the results. And it shows you the actual expression. And I think we went over in detail what an expression can look like. And it gives you the value, the results. So your results are 200.3. So tank 1 here is 144 plus 56.3 equals 200.3. So if you have an algebraic expression, or if you don't want to add all these adds and subtracts and divides, you can just do one instruction and add your expression in there. So that's actually kind of clever. And these expressions can get quite complex, so you want to watch that because it's a little hard to troubleshoot if you don't keep them simple. Okay, so now we've completed the integrated practice programming basic instructions using Logix 5000. We covered the actual compute, math, and move instructions. Next, what we'll cover is the monitoring and editing tags using Logix 5000. And then we'll touch on the forcing and toggling bits using Logix 5000. Now, Logix 5000 course number 2, we went over in depth on the monitoring and editing tags. So I'll try to keep that brief. And as far as toggling and forcing bits, I'll try to keep that as brief as possible as well, so we can get in more into the PID instruction, which is I think a lot of people need a little help in that area. So we'll go over that. The data monitoring program tags. The way you go to this is you go to the data monitoring. You go to the program tags. If you look in the actual toolbar, we can actually flip over to that. Hold on. So when we switch over to the actual program here, you can see the program tags. So if I right mouse click on this, and I can do monitor tags, or I can do edit tags, or I can verify, or I can export the tags, or I can even print the tags. So let's monitor the tags, and you can see this is what we were seeing on that last screen. So these are all the tags that we just created. The results, the tank, the tank divide, the tank multiply, and it gives you all the values here. So you can, in one area, you can see all the values of these different tags. And you can see I'm still online over here. So these tags are actual values. And then it tells you the style. Are they float, decimal? You know, we created a couple of floats. Now, if you recall, we typed in what? Real. We didn't type in float, but we also typed in dint, right? D-integer. A D-integer is a decimal number, and a real number is a float number. So again, this was another example over here of the main program of the data monitoring program tags, and I showed you how to get to it. You go to the taskbar, go to the main task, go to the main program, right mouse click on your program tags, and you can get to this to these information and use this for troubleshooting and what have you. You can also change values from here. You can actually go in here, click on that one, and oh, I jumped in. Click on that and actually change that value. So you can actually do that as well. Here, we'll try that real quick. Hold on. So here we go. We'll say tank, and we'll just type in 500. So tank value is now 500. And you can see that it instantly changed all the values of the calculations. Let's say we say it is 10. And it instantly did all those calculations that we were working on. So you can actually work in the data monitoring program tag screen and manipulate the values. Now, if I was actually writing to that tank value somewhere in there, you could try to change it, but it would just, the program would overwrite you when it does its scan and change it back. Okay. The next section is the actual controller tags. You can actually look around and look at the controller tags. And you can see in this example, the controller tags are actually the physical I/O, and you can actually expand this physical I/O. This is the configuration of, see here we have a card called, it's an input card. It's in slot 2. It's in the local chassis, and that input card has a configuration data associated with it. So you can actually look at that as well, and you can see how we have an output tag or an output card here as well. So we have slot 4, you have an output, an input, and a configuration associated with that. So what I did behind the scenes here is I actually added a card in slot 0, a 1756 IB16. And then, so the reason I did this is so that you could actually see a controller tag, because we previously did not have a controller tag. So when I double click on that, it brings me over to this open window, and it tells me the name of the scope, and the name of the controller is add. And we have a local 0:I. So that's in slot 0 of the local chassis. I have an input card. And I can open it up, and you can see the actual, you remember this is the 2 pound meant it's a binary. Remember that in the previous lesson? So then you can slide this over, and you can look at it. It's a style as binary. And then you've got some configuration data associated with that. Slide it out, and you can see you've got filters. Filters are on or off. And you've got some other configuration tags in here as well. Okay. So monitoring and editing tags using Logix 5000. All of the tags used in the controller can be monitored in the data monitor. This monitor allows you to move through the list of tags in your controller to quickly locate an individual tag. You have the capability to sort this list by alias, alias for, base tag, description, style, tag name, and data type to easily zero in on your data you need. Once located, you can selectively pick the method of or radix, bit, num, octal, hex, ASCII used to display an individual tag. So let's go back to our controller tags, and you can see show all. So if we click this, and we can look at the used tags, produced tags, consumed tags, module tags, can be forced tags. We'll talk about that later. So, and you can remember these are can be forced, or any of these tags can be forced. If we say, we click it, it says none of these tags can be forced. So if we go to controller tags and look at can be forced, and you can see yes, we can force some of these inputs. So we can force the data and the fault tags. Let's see here. Slide this over so you can see the rest of it. And so you can sort by tag name, alias, base tag, description, style, tag name or type. And then you can edit the tag as well. So you can actually add a tag here. Let's double click on this. So again, there's nothing you can't force anything in here, but you can slide through and say, oh, I'd like to see all the Boolean tags, or I'd like to see show all. And the style, you can actually, or the type. See how you double click on that and it actually put it in order. You see how it's actually in alphabetical order. You can double click on this and you can put that in order as well. So you can group all your reals together and all your d-integers and all your floats. Or you can also double click on that and change that and actually put it in alphabetical order as well. Okay, so you have the capability as well to filter the tags that are shown based on data type, and we just saw that, how we were able to filter these. This enables you to show only those tags that fit the data type you select. Finally, you can also view tags by controller scope. Know that you can only see one scope at a time. And what was our what were we looking at? We were looking at the main program. Next, we're going to move to forcing and toggling bits using our Logix 5000. Forcing allows you to override an I/O module's values in the controller. Using the data monitor or the ladder editor, you can manipulate forces on individual tag elements. From either of these, you can force a tag element on or off for tags or bool type only. Remove the force from a tag element. If you want to manipulate all forces in the controller, you can use the online bar or the forcing command from the Logix menu. Once any tag element is forced, the online bar force status will indicate that forces exist in the controller, as well as whether the forces are enabled or disabled. From this bar, you can also remove, enable, or disable all forces in the controller. Okay, so what I did was, I went ahead and added a line of code here. I created a input, the local 0, the card that we added over there. We added it in slot 0. I picked data 13 or bit 13 on that card. And so this is actually I/O, right? And this is just a bit, a Boolean bit that has an internal tag. And so here we have a lamp. So what we're going to do is, one, we're going to toggle this bit on. We right mouse click on it and we just hit toggle. You can also hit Control T, right? So when you toggle it on, the lamp turns on. So this is, obviously could be alias to an output like a motor or things like that. And what this gives you the ability to do is to make sure that your PLC is wired right. So in a controlled situation, you sit down and, working with your different maintenance guys, and you just go ahead and toggle each bit on and off and make sure everything's wired right before you actually run your program. So here we can toggle this off. And again, you hit the right mouse key to do that. Now what we want to do is actually force this input on. So we go force on. And again, that was with the right mouse click. Now you can see it says on here in purple, but the light is not on, right? So you have to go up here to this force window up here, right by your run, and you can see it says forces have been disabled, but there's something out there, because you see how it's turned red on me. So if I slide over here and I say force off, remove all forces, then this turns gray. So if this is not gray right here, this little arrow, that tells you that there's a force installed somewhere. So if you're not sure where that force is, you need to find it before you go forcing it on. So we'll go ahead and turn it on again. Right mouse click, toggle it on. Oh, I toggled a bit. I shouldn't have toggled it. Let's force it. Force on. And then let's slide up here and say I/O forcing, enable all I/O forcing, yes. And so when we did that, this actually turned on. Now we can right mouse click on this and force it off, and the lamp turned off. And then we can force it on, and the lamp turned on. So you can do this with I/O. And of course you want to be very careful about this, because now here I left that in a yellow state, so it says forces were enabled but none installed. Another place you don't want to leave this controller when you ship it. It's okay if you do, but it's not a good practice. So you want to go in here and say off and remove all. Somehow I think we still have a force on. Let's force it on. Let's force it off. Let's remove the force. And then let's disable them. I/O disable all forces. That's what it was, yeah. So now we're back to a gray bar. So now you know how the forces work. And you can actually kind of control your different, you know, your modules and what have you, and test all your wiring and make sure things are working properly. Okay, next, to determine which